calling functions. So we learned how to write the function, and now you're going to see how to call the function within main. In a main program, you call a function by name. So whatever the name of the function is, you write that name. If that function is not expecting any data to come from the main, then the parentheses next to this name will be empty. You do need to have the parentheses. So have the function name with the parentheses next to it. If the function is actually expecting numbers, you saw in the last class, some functions expect data to come from the main program. So whenever they expect to have data come from main program, they will have some parameters inside the parentheses. So if the function has parameters, then your function call has to have values to copy into those parameters. So when you call the function, you need to put numbers, either numbers or the variables that have the numbers will go here. And then the system will make the connection between these numbers and the parameters. So, so before we see the examples, let's understand the rules. If the function is expecting 3 data, for example, if the function has 3 parameters, then you must pass 3 numbers to go into the 3 parameters. It can be 3 variables that have the values or 3 numbers directly. Either way is correct. And also the data types should match. If the parameters are declared as float type, then you should send float type numbers. If you don't send float type numbers, whatever you send will be converted to float. So conversion will happen if the data types don't match. Okay, so let's see how it works. Anytime the function call is executed, it will immediately deviate to the actual function definition and carry out all the instructions in the function. Now, when it deviates to the function, it'll copy all the values that you're passing into the parameters, and then it'll proceed to do the work in the function. So everything the function is supposed to do will be done. I'm going to just quickly use an example to illustrate. I'm going to use average function average that receives 3 numbers. Normally you write the function above the main in the actual file where you type the program. You type the function first, and then after the function closes, you start your main. The pound includes can go before the function or after the function, doesn't matter. They have to be above main. It can be anywhere above main. So I can write the pound include up here. Sorry, my pen is not working properly. Pound include IOStream. And all those other things, and then write the function, which is float average, float x comma float y comma float z. And then inside the function, you have a local variable float av, and then you say av equal to x plus y plus z divided by 3. That finds the average, and then you return, your answer is in average, so you return app. And now you close. Okay, this is your function. Right after that, your main begins. This is how you type the entire program. Main begins, and you can declare float a equal to 3.5. I'm just making up some data here. B equal to 2.1, C equal to 5.8, whatever. And then I call the function to find the average of these. So when I call the function, I need to write average, the name of the function, and then write parentheses. If the average function doesn't expect any values, then this parentheses will be empty. But average function expects 3 values. So I have to pass 3 things, A, comma, B, comma, C. Instead of A, B, C, can I put 3.5, 2.1, 5.8? Yes, you can put numbers right here if you like. But I already have the numbers stored in variables, so I'm passing variables. And then you put semicolon. So when this is seen, when this line is executed, what happens is the system will immediately jump over to the function. So when this is executed, immediately it'll go here and it'll copy the A into the first variable, first parameter. So X will get 3.5 copied. B will be copied into Y in that order, 2.1. C will be copied into this, 5.8. And now X and Y and Z have values. So this will execute to find this. When this is executed, it will find the average. It will store average here for those numbers and then return that average. So when the return is executed, the function, the program leaves, the system leaves the function, and where does it go? It'll come back to the place where it left off. And when it comes back here, where is the answer? The answer, the average of those 3 numbers, that's all. The answer is carried by this entire expression itself. It'll bring back the answer. So that expression, the whole function call has the actual answer. So whatever you want to do with it, you do with it. Let's say you want to add that average to some other variable, or A squared should be added to this. You just add it right there. And then you want to put the result in Y, you do that. So the function call can be written within an expression or written just to make the call. So suppose that you want to make the function call and whatever it returns, you want to just print it. Okay, then this whole thing will be now written as average. See out this. That means call the function, whatever it returns, print it. That's what this means. So whatever the function returns, you can do anything with it, just having that expression, just by having that expression used appropriately. Use that function call expression within another larger expression, or in the cout, anywhere, in any way you like. That's how the function call works. Okay, so now I said you need to write the function at the top and the main afterwards. What if I want to write the function definition at the bottom? I don't want to write it at the top. Can I do that? Yes, you can, but there's a small issue. If you put the function at the top, then the compiler will have no problem with it, because the compiler is going to read everything from top to bottom. It's not going to read one second, let me erase that. It's going to be reading all these from the top to bottom, and therefore, if you put the function at the top, then when it sees the function call down here, this function call here, when it sees this average ABC, this call, it knows average function is there because it has already seen that. It has already seen the average up here. So that order matters. If you put the average at the top, then it'll know that's there. If that function is not there, if you write the function at the bottom, then when it's going to see this function call first, and when it sees the function call, there was no function. It didn't see the function before. So that will be a problem. It will create error message. And that's why you need to say something to the system. on. So a student just came in. Oh,
Oh no, Professor, that was me. My internet went out, so I reached.
okay. All right. Gotcha. All right. So if you put the function at the bottom, then you need to tell the system, I have a function at the bottom. So you need to tell that at the top. So here is how you do that. You just put this function definition. So if you put the function definition at the bottom, then at the top, you need to have what is called function prototype. Function prototype is just the header of the function, the float, average, that, without the names. So let me write that on the board here. For this function float average, the prototype is float average, parentheses, float, comma, float. You don't write any name, no names for the parameters. Just write the types. This is called the prototype. You need to put this at the top so that compiler knows that there is a function called float, called average at the bottom. So it needs to know that while it's compiling your main. So while it's compiling your main, it needs to know that this function exists at the bottom. I already explained how the function call works, so we don't need that. The prototype. So for example, if it is the function square is the one that finds square of any number. The header prototype for that function will be this. So if you put the function at the bottom like this, function square is at the bottom, int square int num. This function receives a number in the variable num, and then it'll find the square of the number and return that. If I put that function at the top, bottom, then I had to have this at the top. See that the difference between that prototype and the header here is the name num is missing. That's the only difference. So it's essentially same as the header of the function without the variable names. You cannot put the variable name. So that's what we call function header, the prototype, and you need to put that at the top, otherwise it won't work. And then the rest of the function, the rest of the main program will be in the middle. Okay. I already explained this on the board, so I don't need to explain. Basically, when the function average is executed, the variables get copied into the parameters. The values get copied into parameters, and then the function will carry out the task. Okay, let's go with this one more example. This function, I'm going to write a program here that uses two functions. One is called write title, which will write the title saying prime numbers, and it will underline with the asterisk. That's all this function write title is going to do. So here's the function write title. It'll write prime numbers and then underline it with the asterisk. Then also we need to use another function called isPrime. That function will receive a number and decide whether the number is prime or not. If the number is prime, it will return 1. If the number is not prime, it will return 0. So it's going to return 1 and 0. You can use it, you can write the function with the bool values true or false. That'll be also correct, but this particular function is written to return 1 or 0. So let me explain the function isPrime. Function isPrime has in return type because it's returning 1 or 0. Isprime is the name, and it will receive a number in the variable val. And then to decide whether this number val is a prime or not, it's going to use the dividers or test numbers going from 2 to val over 2, half of the number, incrementing by 1. For all those test numbers, it'll see if it is a divisor of val. If any one of those numbers, it's a for loop, it's going to test 2, 3, 4, all the way to half of the number. If any one of them is a divisor, then this will be true. This if statement will be true. Immediately it will return 0. Why? If any one of those numbers is a divisor, then it is not prime. So we don't have to test anymore. The loop can be broken. And so we are breaking the loop and leaving by saying return 0. So if any one of those test numbers divide the val, then it will return to the main with 0 as answer. Now, if the number is actually prime, then none of those dividers will divide the number evenly. So this return 0 will never execute, right? If there is no divisor, return 0 will never execute. That's when the loop will go all the way to testing divider equal to val over 2. After testing divider equal to val over 2, if that's not a divisor, the loop will terminate. Only when the loop is terminated, the program will go on to the next statement. The next statement I have is return 1, because if the loop went all the way and terminated, that means return 0 was never executed, means there was no divisor. That's when the number is prime. So that's why when the loop ends, I'm saying return 1. See, when you're writing it as a function, the program is much shorter. Because once the divisor is found, we can immediately return with an answer of 0. Only if no divisor was ever found, then it'll go out of the loop. And there I say return 1, because if it went out of the loop, that means there was no divisor. So by using this return statement, you can shorten your program basically. So that is the function is prime. Now we are going to write a main program that will use both functions. So here's the main program that declares num as an integer, and then call the function right title. Just call the function with a semicolon at the end. This function is not going to return anything. All it does is writing title on the screen. That's why I just make a call to that function and proceed. So this function call will make it write all that on the screen. After that, I'm proceeding to the next one, which says for num going from 2 to 20, because the problem says your program should find all the prime numbers in the range 2 to 20 and write them on the screen. So I'm doing num going from 2 to 20, incremented by 1. Each number is passed on to is prime. I'm calling is prime and passing num. And then if that function returns a 1, I'm comparing the result to 1. If the function returns a 1, that's when the number is prime. So if is prime num is 1, then see out num. And if is prime num is a 0, I'm not doing anything with it. I think at least one student seemed to be having a misunderstanding that for every if statement, there must be an else statement. No, that's not true. If statement can be written without else statement. So here, that's what I need. If is prime num is 1, then see out the num. That means if is prime num is not 1, don't do anything with num, right? Proceed to the next. That's what this means. So because that student who thinks there must be an else is always writing if something like this. If is prime num equal to 1, see out num, else num equal to num. Something, unnecessary, something totally unnecessary. Num equal to num is a wasted statement, doesn't do anything. So do not ever write that. No need to write else. So if this condition is not true, we are not doing anything with num, because that's exactly what we want. We don't want that now. So it'll proceed with the loop, go on to the next number, and it'll test the next number, and so on. So only the prime numbers will be written on the screen. So the output is this. These are the prime numbers, and the program will write them. Prime numbers in the range 2 to 20. It'll write those on the screen. All right, we have a warm-up exercise, and so I want you to do this warm-up exercise first one. One is enough. It says write function max You already learned how to find maximum of 3 numbers. You wrote homework exercises and you were tested in the test on this, so you know how to write that. Now you're writing it as a function. That's the only difference. So this function will receive 3 numbers and it'll find the maximum of the 3 numbers and return the largest. And you must use the technique you learned before. Do not use inefficient methods that we didn't discuss. Go ahead and write it in the chat. I like all of you to try. It's okay to be wrong. You know, you're only learning. So if you're wrong, I'll just explain what is wrong and you learn from that. That's the idea of doing it this way. You don't have to write the main, you just write the function max. I want to see how do you write the function max. I don't see anything. Is anybody writing? Okay, I'm getting one. I think you're, Marco, I think you're mixing up the variable names. You have a variable maxi and then you have another variable no more. I think you meant to have only one of those. Okay, try again. Just edit that to make it right. But the idea is there. The idea is correct. Okay. Okay, that's correct. Okay, so very good. Marco has the right answer, and that's the only one so far.
Call from the leaf of the server. Call from the leaf of the server.
Hello? Uh, Nobody else wrote anything. All right. I'll it's not difficult. It's a very simple idea. Anyway, I'll go ahead and write that. So the function max is going to be float type because it's going to receive float type numbers. So float max and float A, float B, and float C. It's going to receive three numbers, so you need three parameters. And then inside, to hold the maximum number, you don't use the same name as function name. The variable name you introduce has to be different from function name. So I'll declare float M. It doesn't have to be anything more than that. And copy A into it. The technique is to copy the first number into the max variable and then compare all other variables to max. You learned that technique before. So if B is greater than max, then max, copy the B into max, max equal to B, only if it is greater. Only compare each number to the max. That way max will keep the largest always. So if C is greater than max, max equal to, sorry, M equal to C. Oops, M equal to B. And that's it. So after these statements, the largest one is copied into M. M has the largest. So return M. Now that's the function. The problem says now write a main program that will get three numbers from user and find the maximum and print it. So you need to declare float X, Y, Z. X, Y, Z will have the numbers, three numbers that we are going to pass into ABC. So can I call these X, Y, Z ABC? Yes, you can. But then you may end up mixing up those ABC and these, they're different. These ABCs, if you declare ABC here, they're not going to be recognized in the function, and the variables in the function are not recognized in the main. They're all totally independent. So you could use ABC if you like. I prefer to use different names. See out, enter 3 numbers, ask the user to enter 3 numbers, and see in XYZ, and then call the function max and pass XYZ, and whatever it returns, this whole thing will carry the answer. I just want to print it. See out this. So that will print the largest of the 3 numbers. So that's all you need to do there. And that one example is enough. So let's proceed to see the facts. I already explained these facts. If there are 3 parameters in the function, 3 values must be passed. The number of parameters, number of values you pass must match. The functions can call other functions, but no other function can call main. Main is also a function, as I explained in the last class, but no other function can call max. But a function can call a different function. A main can call many functions. Main can call one function, and that function can call another, and so on. Those are also all allowed. Variables that are declared within main or within any function is local to that function, and it's not going to be understood or recognized in any other function. So those are the basic ideas. Yeah, this example is going to illustrate that a variable declared in one function is not recognized in the other. I have an M here and an M here, they are independent. They are different M's. That's the point I'm trying to make. So other than that, this example doesn't serve any purpose, so we are skipping that. So we are finished with that, and your assignment is already there. And so moving on to the, to section 5.3. 5.3 is about function libraries. Okay, so let's understand libraries. Now you can see that a function and a main are 2 separate things. So that means functions can be written by others, and we can use them. So functions written by others can be used. So that's one of the reasons why this idea of function is a good idea. We are able to take advantage of work done by others. That's one of the reasons. So there are hundreds of functions already written by others, and they are available in libraries. There are several libraries out there, and each one has hundreds of functions, and we can use them. To use them in our program, all we have to do is include that library as part of our program. So you do that by doing a pound include. Remember, we have been pound including iostream.h, the iostream library. That's a library that they have been including. That library has input-output functionalities. Only that library makes the cout and cin understood by the compiler. So that's why we have been including that library. Now, if you want to use these other libraries, all you have to do is pound include. Once you include, all those functions are like they are at the top of your main. So they are right there. And you can call any of them within your main. So any function in the library can be called within the main if the library is included in the program. So let's understand math library first. You can include the math library. Math library has all the mathematical functions. And to include it, you just pound include math.h. at the top, where you wrote pound include iostream or iostream.h. You write this also. You write this in addition to that, and then you're including this library. Once you include this library, you have access to all the functions in this library. This library has hundreds of functions, but we don't have the time to learn about all of them. We will go over only a few that are important to us in this course. In this course and in the course coming up next in both computer science majors. In these two courses, you'll be using these functions, and therefore we are going to go over these. But there are hundreds more functions that we are not going over. If you become a professional programmer, then you will be forced to learn all about them. So let's discuss these. Fabs is a function you can use to find absolute value of any variable. So if you pass the variable n, you call fabs and pass any variable, it'll find absolute value and return it. Ceil function will find smallest integer larger than the number. So if you call ceil function and pass 2.5, it'll return 3. The closest integer bigger than the number. And floor does the same thing, but it finds a smaller integer, lower. These functions are not rounding. They're giving you integer below or integer above. So which the ceil stands for ceiling above, floor stands for floor below. So to mean that above and below, they use these names. EXP stands for exponential function. It'll find e to the power n. If you call EXP and pass n, it'll return e to the power n. Log function finds natural log of any number. Log 10 finds common logarithm with the base 10 of any number. Now, after this, we're going to be using these functions. Very commonly, students mix up these two functions. What is written as log is natural log. So if you need to find common log, it's log 10, a different name. Okay, in the past, we couldn't do exponents. Like, remember, we couldn't do things like, I'm writing on the board, 5 to the power 100, anything like that. We couldn't do that, right? We could do 5 squared and 5 cubed and things like that by multiplying 5 times 5. There is no exponent in this language. So we were doing these. So there's no exponent, still there's no exponent in the language. So there is a library function that someone has written that will find exponent for you. These functions use some other technique. They're not using multiplication like we're doing here. Some other technique to find these larger powers in a faster way. And you'll be learning techniques like that in the advanced computer science classes. Techniques for finding things in a faster way. So these functions already written for us, and they will find this function power will find power of m to the power n. So if you write power m comma n, that means m to the power n. The m is the base, n is the exponent. It'll find that. But if it uses some other technique that is a longer process than multiplying 5 and 5. So therefore, you use it only if you need to find higher powers than 2, 3, and 4. If you need just 5 cubed, you're writing 5 times 5 times 5 is very efficient way to do it. This will find it faster. But the power function is useful to find larger exponents that we cannot do without that function. SQRT function finds square root. And so you pass any number to it, it'll return square root of that number. Now, finding square root is a very long process. The method used is called power series method. You're not even ready to understand that until you learn calculus 3. So I cannot explain those techniques, but these are advanced techniques. So you use them only when you need them. So that's why I'm saying power function should be used only for large exponents, not for small exponents. Square root, even though your calculators find square root, they're also using the same power series method. They're all programmed to find square root using those methods. Use that function to find square root, and sine function to find sine. This is trigonometric function, sine. Sine of any angle you can find, cosine. Similarly, similar to sine, and tangent, cotangent, all those are there. But I'm only discussing sine and cosine here because the rest of them are obvious. These functions you need to know how to use. We will see some examples as we proceed. Okay, so like this example, I'm doing C out is QRT10. I can just call square root function and pass 10. It'll find the square root of 10. And this is the answer I found. The pow function, pow 3 comma 10 is using pow function to find 3 to the power 10. And here's the answer. Those are just some quick examples. And here is how you write mathematical expressions. You can do these now. In the past, we couldn't write these in C++. So this formula here, these formulas can be written. So the first one is written this way: minus b plus square root of b times b minus 4 times a times c. So right there, this QRT is the only difference. Sorry, I ended up messing it up. So anyway, this second expression here, x to the power 7, can be now written as pow x comma 7. Y to the 7 is pow y comma 7. So we can write those expressions. Now here the log x in the third example actually means common log, because in math we write ln for natural log. So when I write log, that's common log, you have to write it as log 10 right here, log 10, not log. So what is written as log in math has to be translated to log 10 in C++. X to the power 5 is pow x comma 5. So all these complicated expressions that we couldn't write program for, now we can write programs using library functions. All right, so going on to simple example. This is a program that will get numbers from the user until he enters Sentinel 0, and it will add up all the square roots of those numbers. I'm getting the first data before the loop, and while that number is not 0, if the number is positive, find square root and add it to sum. There's no square root for the negative numbers, so we had to do it only for positive numbers. And then get the next number and proceed to do the same, adding up only the square roots of the positive numbers. So that's all you need, very simple. You have now a library of functions you can use. Now the IO manip library. This is, it's called IO manip to mean input-output manipulation. You can manipulate input and output using functions here. We are not going to manipulate input in this course. We're going to do only output manipulation. In the past, you used cout statement with no control on what cout statement writes. So if the answer has 15 decimal digits, the cout statement will write all of them. Sometimes you don't want them. You want to, in the past, we learned how to round them to 4 digits and 3 digits. So suppose that you just want to write 4 or 5 digits, you don't want all of those digits. And that's one thing. And in the past, when you use cout statement, all your outcome will line up on the left, on the black screen. your output will be all lined up on the left end. What if you want to line them up on the right, right justified or center justified? Can we get that? Well, that's what we can do now with this IO manip library. We can get any kind of manipulation of the output. So now we have some control over the output using these functions. So first I'm going to explain those functions and then we will see how to use them. Set width, SETW is the name of the function, and we call it set width function. It will write the output within that width. So when you say set width and then 5, if you put a 5 in the parentheses, set width 5 means write my number within 5 spots. A spot means a spot used to write one character. So use 5 spots to write the number. Means the number will be, of course, the number has to have smaller than 5 digits. Otherwise, you'll be losing some digits. And you are asking it to actually use 5 digits. So 5 spots. Then within the 5 spots, the number will be right justified automatically. And any blank space will be in the front. Now, set precision means you're limiting the number of decimal digits, the digits after the decimal point. So if I say set precision 5, that means I want 5 decimal digits. If I say set precision 4, I'm asking for 4 decimal digits, which means the number will be rounded to fit into the 4 decimal digits. So this function will round it for you, but it's only good for outputting rounded number. If you need to round the number within your calculation before outputting, then you have to use the methods we learned before. Now I have this page messed up. Sorry about that. I messed up by typing something, but as long as I don't save it, it'll be fine. But the set IO is flags is the other function. This is the function. This function is used to set a flag, and the flag can be one of these. Flag equal to IOS : write. That means you're saying everything I write after this function is executed will be right justified. Similarly, you have IOS : fixed means you're saying I want fixed point format. What is fixed point format? That is the normal format we use for fractional numbers, 5.6795. That's the fixed point format. What is the other format? Scientific format. Sometimes the system automatically chooses to write your output in scientific format when it is too big or too small. And you can now force it to write it in fixed format, the decimal point format, instead of scientific format. So if you use flag equal to IOS : scientific, that means give me scientific format answer. IOS : show point means show the decimal point. So sometimes the decimal point is not printed when there is no digit behind it. This will force the system to print decimal point regardless of what happened. So those are the input-output manipulation functions that we are interested in. I'm going to show you how they work using examples. So here's an example in which I set m equal to 5, and then in a loop, I'm writing many numbers. Cout set width 5. See, this is how you use set width. After the cout, you write set width 5 and then write m. That means m should be written within 5 spots on the screen. M is 5 right now, so when you write it in 5 spots, you have 4 blank spots. The 4 blank spots will be in the front, so the 5 will be at the end. Then the number changes to 50 here, and then it's going to re-execute the cout statement. It's in a loop. So now you're writing the 50 using the same set width 5. So it'll write the 50 using 5 spots, and so 3 spaces are in the front. So as you can see, so now you can see what happens. 500 is written with the same method. So 1 blank in the front, 2 blanks in the front. and so on. So the numbers are now lining up on the right. They are right justified. So as a result of using set width, your numbers are getting right justified. So if this is how you want the numbers, then this is a good idea. If you don't use the set width, then all these numbers will be left justified. You have seen that before. If you don't manipulate the output, they will be automatically, the default is left justification. Okay, and let's see another example of set precision. Float A equal to 22.0, B 7.0. I'm dividing those numbers, and then to write the output, I'm using set precision 3 to write C. So that means round my number to 3 decimal digits. The actual answer is this, 3.1412 on that. If you round it to 3 decimal digits, it will be 3.143. And that's what it'll write right here. And then next cout statement says set with 5 and then set with precision 2. You can do that. You can combine all these functions. So you're saying use 5 spaces to write my answer, but round my answer to 2 fractional digits. So it'll round it to 2 fractional digits and then use 5 spaces. When you count the 5 spaces, 1 space will be used for the decimal point. So therefore, the answer rounded to 2 decimal digits will be 3.14. And how many things are there? 3 and the point and the 1 and the 4. 4 things are there. So there will be a 1 blank space in the front because you're doing set with 5. Now remember, if you don't use set with 5, if you use set with 3 or something, then you're dropping some of the digits. No, if you use set with 3, yes, you will lose the last digit. So your answers will be wrong if you don't use enough spaces. So set with 5 is okay because there are only 4 digits in the rounded answer. So there will be 1 blank in the front. So the output will be this. There's 1 blank in the front, as you can see. All right, so that's how the set precision works. No, we will discuss that. We will not go into the other library, but quickly I want to show you how to use the other function. So if variable B has the number 3.1415, something like that, and you want to write that with the right justification or anything like that, then you say cout set iOS flags, parentheses, flag equal to any flag you want. So let's say scientific. And then B. That's how you write that. Call the set flags function and set the flag, and then write the B afterwards with an arrow. That means convert B to scientific format, basically. It will convert the value of B to scientific format and write it. That's just one example to show you how to use the set iOS flags. I didn't have any other example in that display. So, so I wanted to show you that. Anyway, that finishes those libraries, and we will do the standard library in the next class. And so for now, we are done.